As we just learned with Wireshark, there's a lot of data that can be captured on the network, and one of the things that we're going to see is protocols. And you will have to understand the foundation of what a protocol is and how it works on your network. Basically, as we already covered in Module 1, it's going to encapsulate your data. It's going to add some data to the traffic that's flowing to give it some more information so that at each layer of the OSI model, systems know what to do with it. For example, if at layer 2 it's just a MAC address, what's going to wind up happening is you're going to see MAC addresses in the capture. So what happens when it moves up to the layer 3, the network layer, as it's going through a router? Well, at this layer, you're going to now have IP addresses and you're going to have routing information. So at each layer of the OSI model, there's going to be more information added to the packet or the frame if it's at layer 2. In this course, we're predominantly going to call everything packets, even though there's segments and there's frames. But at this layer, let's say at layer 3, at the network layer, the packet's going to contain a lot of information within it, so that when you do capture it with Wireshark and you look at it and you analyze it, it's going to give you information such as source IP, destination IP, and so on. In this module, we're going to take a very simple protocol and we're going to take a look at it in a way where we can see with Wireshark what we're capturing and why it's so important to understand a protocol, so that when you do capture it, you know what to do with it. You know what it's supposed to be doing on your network. So as an example, and we'll look at this in future modules, if you capture ARP or you capture ICMP or you capture TCP, what are those protocols really supposed to be doing? So when you talk about ICMP, or Internet Control Message Protocol, one of the things that it's responsible for doing is providing error or problem information on your network. So some of the tools that uses ICMP is a simple ping or a trace route, and it's used to troubleshoot network connectivity. Now, when you capture it with Wireshark, and on the screen is a simple ICMP capture, you're going to see traffic flowing through the network from a source to a destination address, and you're going to see in the protocol column ICMP. Now, in the information column, you're going to see specific information like echo, and you're going to see echo request, echo reply. So if you didn't understand how the protocol ICMP actually works, when you open up Wireshark, you really wouldn't understand what it's really telling you. So some of the ways that you can learn more about protocols is to read RFCs, requests for comments, do some research. There's some good books that you can read. But predominantly, and the way that I've done it in the past is every time I run a capture and I find things, it immediately sparks interest in me to dig deeper into what that is and how it actually operates on the network, what it does. Now, as we learn networking fundamentals, there's certain things that we have to know. We obviously have to know how IP works. If we want to configure a router or a switch, we have to understand if you're going to configure an IP address in it, if you're going to build how the routing is going to work. You have to understand the fundamentals of it. This simple protocol that we picked for just to get you through foundations beginnings here, ICMP, we have to understand how that works. We're sending pings across. We want to know what the TTL is. We want to understand what that really means. Well, we have our ways of doing that as network professionals, and we know if we're going to send a ping, it'll tell us destination unreachable, possible routing problem. There's certain things that we understand, but if we actually captured the data, what would that really mean? What would that mean to us? So obviously we're going to use Wireshark to capture this traffic from source to destination, and again, that's the most important thing. If we want to send a ping or a trace route, and again, this is a simple example, and we were trying to get across, let's say we couldn't ping something, why? So the quickest way to do this would be to set up Wireshark on the two endpoints and start capturing the data. So let's say I'm at a source client and I'm running a ping, a continuous ping, from the source to a destination. Let's say it's just a file server, and it's continuously running, it's running over and over, and I see nothing but drops, or I see milliseconds that are very high and then very low. Why would that be doing that? Well, as we mentioned already in the earlier module, we would want to look at first, hey, let's run a trace route. Let's see if there's something else that we don't see. Maybe we do have access or don't have access to the routers. Let's take a look there. But if we were only limited to using Wireshark and we just installed it on the source and the destination, what exactly would we see? Well, if we did so, we would see that we would capture data that looks as if in here that we had a ping request, and we would look for replies, but we'd see identifiers, we'd see sequence numbers, we'd see some specific data that may or may not give us a clue as to what it is, but in some instances it may. So again, it may not always tell you what the problem is. You may have to do a little bit deeper diving using tools outside of Wireshark. But just remember, if you were looking at the actual packet, there's information in the actual packet that maps to other things. So what do we use ICMP mostly for? We use it to use ping. We use it to do trace route. It's part of the TCP/IP protocol suite. It relays query messages, and it uses control messages. So what does this really mean? So one of the things that's important to understand with ICMP is that this is actually the information that's appended as the packets are moving and up and down from the client source to the destination. And in here you can see some of those exact things that we were just talking about. You can see the source address, the destination address, options, the time to live, the checksum. Those are the things that when you learn about the protocols themselves and you do deep dives into the protocols, it will provide you the information so that when you capture it with Wireshark and you look at the data in the details, you will understand deeper information about what that actually means. Now, when you do filters, you'll also be able to build filters based on this information. For example, if you wanted to build an offset filter, specific hexadecimal code could be used to build filters to search for information that may or may not be in these headers. So this is one of the key things to remember about protocols when you're troubleshooting them with Wireshark. So when we're doing traffic flow analysis with Wireshark, and again with the protocol ICMP, some of the things that we're going to be looking for, some drop packets, maybe an incorrect gateway assignment, it's taking the incorrect path, maybe there's latency. There's many reasons why the data may not be getting from source to destination either in an appropriate time. It may not be getting there at all. It may be taking an incorrect route. Whatever those things are, those things could be found when you capture the data from the source and at the destination and analyze both captures to see specifically what that protocol is doing, filter for ICMP, and specifically look inside the data to find the information you need to get the clues to solve that problem.